Before we continue forward with any sort of JavaScript, there are a couple of important ES6 methods that I wanted to discuss because they actually help you achieve a much more flexible code and a much more readable code. And in this video, we'll be discussing about 4 ES6 methods that are most commonly used in modern day JavaScript code. So let us get started with iDigitalPreneur. Now, the first important ES6 method that we're going to see, and we already saw this in the previous video, is the spread operator. Now, the spread operator is actually denoted by a pair of three dots, and the spread operator, its use is basically to spread out the values of either arrays or objects. So what do I mean by this is, let's say I have created an array1, and I put it to be 1, 2, 3, right? And now I created another array2, and now I wanted to spread out or kind of even out or basically copy the values of array1 inside of array2. I can use a pair of dot operators like this, or like a triplet of dot operators, and I can put in the array name something like this. And now if I do console.log of arr2 and run my code again, I am going to get the actual array here. So basically this is a way of taking individual elements of either arrays or objects and kind of spreading it out into a new variable whatsoever. The same thing can be done with objects. So I will say, let's say obj1, and we already saw this example in the previous video. I have my a of 1, b of 2, and I have, let's say, const obj2, right? And I wanted to kind of copy these properties of obj1 inside of obj2 first. So I will just spread it out obj1 like this. And let's say I wanted to add more properties to my obj2. So I will say, let's say c to be 3 and d to be 4. Now, if I do a console.log of my obj2 and let's run this, let's comment this out. So you will see that I am getting all of the properties which I copied from obj1, including the properties of obj2. So the spread operator is a great way if you want to copy things from arrays and objects, and it is also used in destructuring, which we'll see at a later point of this video. But spread operators are a great way to copy stuff from arrays and objects and directly create a like a shallow copy of things. Of course, if you want to do a deep copy of objects, we use the structured clone method, which we already saw. And because we don't have the concept of deep copying and shallow copying in array, if you do a spread operator and if you copy stuff up, it will copy up the entire thing. So this is what there was to spread operator. Now we will see about the rest operator. So the rest operator, again, it is denoted by the same three dots, but the context of the rest operator is a little different from the spread operator. And the rest operator is essentially used with functions. So I will create a function, let's say biodata, right? And inside of this function, I am, let's say, just returning a string, right? I'm returning a string which says your name is, and then a pair of first name, right? Or name, right? Your age is, let's say, something we have passed in a variable age. You have, right? You have certain hobbies. So I will just spread out the hobbies like this, right? And now you will see the moment I did this, right? It's not actually taking it up. So probably I will just, I will, instead of putting it inside of my string, right? I am going to return everything. So let's remove this. Let's do a return of other info, right? And now I have my name, I have my age, and I have the other info, but I'm using a rest operator here. Now, what do I mean by this is anytime I am creating a function, right? And I am not sure of the number of arguments that are going to get passed inside of my function, because other info can hold a lot of information. It could have 10 like 10 values, it could have 20 values, it could only have 2 values. I'm not sure of the exact number of arguments that is going to get passed, and that is why I cannot give a parameter to each of the arguments, owing to the fact that I don't know the number of total arguments being passed inside of my function. So this is where the rest operator comes into the picture. I am simply resting out the operators. I'm delegating this thing to JavaScript, that okay, no matter how many number of arguments comes in after the first 2 arguments, you return all of those inside of an array. So let's run this code, right? Let's run this code, and I'm going to give this a name of age of 30, and now I'm going to give maybe 2 to 3 other arguments here. So let's say I give it uh, B, and then T, and then S, right? So B, T, and S, these are something which are part of the other info argument, right? And because I'm returning other info, right, I can store it up inside a pair of result, right? So I'm going to say result1. And now if I do console.log of result1, right? If I run this, I am going to get all of my other arguments which I passed inside of my function inside a pair of array. This is what the rest operator does. And no matter how many number of arguments that I keep on passing here, let's say I pass something like this, right? I keep on passing something like this, and no matter what the arguments are after the first 2 arguments, all of those arguments are being denoted by one variable, which kind of made things simpler for us, because now I don't need to think about anything apart from name and age. All of the other arguments are being namespaced as other info, and I'm returning that other info inside a pair of arrays so that I can easily manipulate that data. This is used to kind of dynamically calculate the number of arguments, and the rest operator is only used in context of a function. Although the spread operator and the rest operator, both of them have a similar syntax of 3 dots, but the way the spread operator works is a lot different from what the rest operator does. And you can see that the rest operator is not creating a copy of something, rather it is taking up all of the remaining or resting arguments and placing them together inside a pair of arrays. So this is what the spread operator and the rest operator does. Now we'll move on to the template literals, and we already have been seeing template literals a lot. If you remember from the first video where we discussed about data, I think it was the second video where we discussed about the different data types in JavaScript. We saw how to create strings or concatenate strings, and how we could dynamically inject variables, and that is exactly what template literals do. Literals are a way of constructing a dynamic string without the use of concatenation in JavaScript. So if you remember, and let's recall our example, let's say I created a variable by the name of first name, right? And that is, let's say, A, and I have another variable by the name of last name, which is B. And now let's say I wanted to construct a string. Now before template literals, the only way to construct a string was to use the plus operator to concatenate stuff, and then we had to make sure that the spaces were added, because spaces were another characters themselves, and it was kind of a mess whenever we wanted to create a heavy text formatting in our code. So let's say I wanted to create a statement of your full name is, and then the first name and the last name combined. The old way of doing it was using normal strings. So your full name is, and then I would add in a pair of space, and then I would go ahead and add in the first name like this, and then I would give it a space again, and then I would give it a last name. Now if I ran this code, then I would get the entire string. So your full name is AB, right? But this created much more problems because as and when our string grew, we had to concatenate a lot of white spaces and strings and variables in it. To kind of make our life easier, template literals came in with a pair of backticks. Now, instead of using single quotes or double quotes, we use a pair of backticks, which can be found on the left key of your one number key on your keyboard. And now you can write out your statement exactly, or you can write out your string exactly how you want it to be formatted. And whatever formatting you do here will be respected by JavaScript. So you can write your full name is, and then if you want to inject any sort of JavaScript expression or a variable inside of the string, you don't need to do a plus concatenation. You simply use the dollar sign with a pair of curly brackets like this, and inside of the curly brackets you can put in the JavaScript variable which you want, right? And then space, and then I want to insert the last name as well, so I will say last name. So this is a much more cleaner syntax than the syntax which we saw earlier. And if I run this code now, you will see that I'm getting the same output, that your full name is A and B. And because the template literals kind of respect your actual formatting, this also paves the way that you can construct multi-line text, right, using some escape characters. Now, this is something which I'm not going to discuss, but because template literals allows us to create multi-line strings in JavaScript, you can actually go ahead and create all sorts of different paragraph formattings. You can give white spaces, tab spaces in your paragraph, and all of that formatting will be respected by JavaScript. And it also gives us the power to kind of insert some sort of a JavaScript expression between the strings as well. So if you don't want to insert a variable name, let's just uh, try giving it a JavaScript expression. So I'm going to say 2 plus 2. And here, let's say I give it 4 into 5, right? Let's run this. And now you will see that the calculations are automatically done by template literals, because whatever I type inside a pair of this dollar curly braces is considered to be a JavaScript expression. Now, of course, you cannot declare a variable here, but you can definitely execute a function. You can do some sort of a computation like arithmetic operations, or you can insert variables. Any sort of a JavaScript expression works here, but you cannot do much more complicated things here. So let's do one more example of, let's say I created a function which says, say hello, right? Say hello, or it just returns, right? It returns a string which says hello user, right? And now let's say I wanted to add this string from the execution of this function inside of my console.log. I can simply go ahead and inside of my JavaScript expression, I can say hello, right? And execute the function like this. Click on run, and now it will execute the function whatever it is returning, because it needs to return something. You cannot have a function not returning something from inside of it, otherwise this value will be undefined or it won't show, right? And it is giving me your full name is hello user. Hello user is because of this say hello function getting executed. So template literals actually give us a lot of flexibility over how we can integrate a dynamic string with all of these JavaScript expressions and variables and arithmetic operations. And it helps us create a much more powerful, compact string manipulation technique. Now, the last thing that we are going to see is something called destructuring. Now, destructuring is a way with which we use the rest and the spread operators, so the three dots. We use it to kind of extract values which are more useful to us. Now, for example, let us take an example that I have created this object of like simple A, B, and C, pretty much the same way what we are taking right now. And inside of my D, I have a pair of object itself. And here I am doing maybe some other properties, right? Something like this. And let's say R is again an object, and inside of R I have Y 34, right? Or let's say 55, Z is 66, and then K is 77. Now I have created a complex looking dense nested object. Now let's say I wanted to access this K. Now in order to access this K using the conventional dot notation and bracket notation, we have to do something like this: console.log of obj, then inside of dot d I have dot r, and inside of dot r I have K. Now, if I do this, then I will get the value of 77. Now, although this is fine, but what happens if your object becomes heavily nested? Every time you wish to access this value of 77, you actually have to write out this entire line of chaining of multiple key names, and this kind of becomes problematic, and this kind of becomes cumbersome and verbose. To kind of tackle this, we have the concept of destructuring, and what destructuring says is that you can extract out a single key name from object, and you can use that individually inside of your code. What do I mean by this is I will use the const, and then you can use const or you can use let, whatever you want, and then a pair of brackets, curly brackets, which kind of denotes the object, and then you give it the value of object. Now, this is a weird looking syntax because you might think that, okay, I'm declaring a variable name by this pair of curly braces, but inside of this object now, I can go ahead and extract out that key. So I will say that this D, because my K is present inside of my R and R is present inside of my D. So I will say const D is equal to object. Let's first of all go level by level to see what destructuring is actually doing. So if I do this and now I do console.log of D and I run this code, you will see that I'm getting the exact object, right? Or the exact object which is held inside of the D. Notice that here I'm not doing obj.d, rather I'm just using the namespace or the key name which was associated inside of the object. I am just using that key name to extract the object. So we have kind of extracted out that particular value via the key name, and now we can only use the key name and not the dot operator or the square notation operator to access that value. Now pretty much the same way, if I want to access K, right, inside of my D, I know that D is an object. So inside of this, I will again start a destructuring sequence, and here I will put in R, right? And now let's see what R is. If I run this code, I should ideally get back this object of Y, Z, and K. Now, instead of doing obj dot d dot r, I am simply doing r because this object has been extracted into its own key name namespace, and I can simply use that key name directly outside of the scope of the object. Now, because R is another object and K is inside of that object, inside of my R, I will again start a destructuring sequence like this, and here I will extract the value of K. And now if I do K and I run this code, I am going to get the value of 77. And 77 is there. Now, if I wanted to use this 77 any place outside of the context of my object, I can simply use the value K because this value of 77 has been extracted to its own namespace. So object destructuring is a really great way to extract out only those relevant key names which you require, and you don't actually have to use the dot operator or the square bracket notation to kind of create this long ugly looking nesting sequence to access a certain nested value key value property. Now, destructuring not only works with objects, it also works with arrays. So let's create an array and see what we can do with arrays. So I'm going to create an array of 1, 2, 3, 4, 5, right? And now let us say that I am only interested in the first two elements of my array. Now, of course, I can go ahead and do ARR of 0 and ARR of 1, which will kind of give me the first and the second element of my array. But let's say I wanted to extract them out into their own separate variables or their own separate namespace. So I can use the similar syntax what we did in objects. I can say const and then a pair of square brackets because objects are denoted by it. And now I will give it the name of the array which I'm trying to destructure. And now here I can go ahead and write out the name of the variables, and the order of the naming of the variables will be maintained. So if I say A, comma B, comma C, comma D, comma E, something like this is equal to array. Let's do a console.log of A, comma B, comma C, comma D, comma E. And now if I run this code, you will see that A has a value of 1, B has a value of 2, C has a value of 3, D has a value of 4, and E has a value of 5. So I've extracted each of my elements of the array into their own separate variables. And now instead of using the bracket index notation of ARR0, ARR of 1, I can simply use the variable name like this to access that particular array, which is what is evident here. Now let us say that I wanted to skip out on the third element. I did not want to extract out the third element. So I can simply remove the variable name, but the commas need to be separated like this. Now if I do A, right, A will return 1. Similarly, B will return 2. Now, if I do D, ideally you might think that it will return me 3, but I am skipping 3 by putting an empty space here, that between the pair of commas, I'm not writing a variable name, rather I'm just skipping it. So now if I do D, D should ideally return me 4. So this is a great way of actually extracting out only those elements which you want to extract out into their own separate variables, you both in objects as well as arrays. Mostly destructuring is quite useful in objects because you have to write a lot of verbose nesting using the dot operator and the square bracket notation. But even in arrays, it's possible to kind of destructure the individual elements and put them out into their own namespace if that is your particular use case. This brings us to the end of what destructuring is. We discussed a lot of ES6 important ES6 features and methods, right? These will be helpful in the later point of time when we are writing much more complicated JavaScript code and kind of manipulating HTML and CSS using JavaScript. We still have a couple of things left in JavaScript before we start off with the DOM manipulation. So I will see you all in the further videos.